The blood flows. Does what?
Were you asking about the blood vessels or the capillaries?
Well, capillaries are blood vessels. What do they do? Now, when we think of blood flow, we tend to think of all these bigger vessels that we kind of see in pictures, but the true activity is at the capillary, right?
Well, it's where like the exchange of everything happens between those blood vessels and the
Exactly, because at that level of the capillary is where our blood flow is meeting actual cells. That's what's occurring. Do you remember this term right here? Neuroglial. All right, well, neuro, of course, meaning nerve. Glial. And remember that from part one? Glial are going to be support cells. All right? These are support cells found throughout the nervous system tissue. They're really cool. And that is what they are, support tissues. That's what they do. Okay? So, these nerve support ependyma, which is the type of cell that's present, okay, lines those ventricles. Lateral, the median, the aqueduct, okay? Their job, produce the CSF. All right, hold up. Think about this for a second. We have said that there is the choroid plexus present, a mass of capillaries. Now I've got these support cells. What am I saying? There's a close relationship between them.
circulatory system,
My circulatory system and my cerebrospinal fluid. Therefore, it's very plasma-like. Have you ever seen the separation of a blood sample where it separates out into the red blood cells, the plasma, the buffy coat? Well, think about blood that gets drawn, okay, gets put in a tube. If needed, the tube can be put into a centrifuge, spins it really, really quick, and when it's done, it's broken down based on the weight of the molecules. Red blood cells are the heaviest, so they tend to settle at the bottom. White blood cells create a little buffy coat, and then the top portion is plasma. Kind of this yellowy looking type substance that's filled with electrolytes, protein, all these nutrients. Okay? So it's very plasma-like. We're going to see that as the blood plasma comes through, it's going to get modified by the ependyma. It then gets to flow through and around. So it washes over all the tissues, the central nervous system. Yes, helps with buoyancy, keeping it a little bit protected. It has chemical stability. Chemical stability. What could that refer to? And if we're thinking of homeostasis for chemicals, one thing that the brain needs to do, maintain pH. pH involves the gases, okay? And it's going to want to make sure that materials that could be toxic or harmful to those cells don't really make their way in. Some do. Alright? But the job, hopefully, is to not let it get through. And it is constantly produced. This is how it flows. Make sense? I bet it does. If I have my two lateral ventricles, meaning each half, that's representing number 1. 1 has to flow into the median. 2 has to flow into 3, which is my cerebral aqueduct, which has to make its way down through the central canal to wash over all of the tissues. Then, as I wash over all of the tissues, fluid begins to travel back and around and through. Now, if I had, at this point, my spongy area, the capillaries, all right, this is bringing the blood flow into, for making the CSF. The CSF, as it washes over everything, is going to be supplying nutrients, it's going to be picking up waste, and that has to be gotten rid of. So what happens? How is it that we get that fluid and all the waste out of it back to the bloodstream so that it can be cleansed, so that we can get more blood flow to make more CSF, to get rid of more waste, to get it back to the circulation system, and get everything moved back? How do I have that connection? Trace your flow. Trace the flow. Well, now the aqueduct is going to actually take it down into the spinal cord and help wash over those tissues and then return it back, but it's still. Do you notice these two little bulging areas that are being represented at the top? Part of that arachnoid area. Wait a minute. Hold up. Calm out. Why is it called arachnoid? What made up the spider webbing? My vessel. And the vessels have the connection to what? Blood vessels. Any idea for every time your heart beats and blood leaves by way of the aorta, and then the aorta, as it begins to do that descending, offshoots these arteries so that we can feed into the brain and the upper extremity before descending and supplying all the rest of the body. Any idea for every heartbeat that occurs in your body, the percent of the blood that travels to the brain? About 70. The blood supply to the brain is tremendous. And the body, when that heart beats, it's going to be supplying as much glucose as possible to the brain tissue, because that's the only thing that it can use. If you don't, like, you know, a lot of people who stay on these low-carb diets and all this sort of stuff, I mean, seriously, I begin to wonder what's happening to their brain cells. Seriously, I mean, I'm like, what? Because your body will make sure that it feeds the brain first. And if it doesn't have it, and it has to make it, things can really get not pretty if it has to start making it itself. So it's like, I gotta make sure. I mean, I'm losing neurons by the thousands on a daily basis. And I'm like, I need to lose some more.
If it's making it, how long will it actually last until after that?
People who do like the low carb, seriously, I mean, like, I know this girl, and bless her heart, she's just being abundant, okay? You know, but she, I mean, if she won't let, if she knows the carb is passing, you know, I mean, she will not touch that food. She has absolutely no muscle mass in her body, none. I'm just like, I mean, so much is broken down, because if the body doesn't get it from your diet, the first place it's going to break down is your skeletal muscle. It's like, I just don't know if that's healthy. I really don't. But
You carbs, other places, other people who take that as a traditional carbohydrate, especially with that a lot of carbohydrates.
and see, she won't even.
Yeah, exactly. People go on these low carb diets, they're actually not supplementing with the proper foods to actually make it like the reason they should.
And I mean, it's like, it's painful watching her eat. Because I'm just like, what is she eating? Nothing. Pretty much. Nothing. Believe it or not, North Carolina. I know. So, it's important. This fluid is washing over. It's providing nutrients, getting rid of the waste. The structure that we get to create it. Have you guys ever heard about the blood-brain barrier? Brian, how shake your head. What does it do?
I remember like back in high school, I think it's something like this, video, kind of self-monitoring, something like that, and didn't let anything pass through. I forgot what.
Okay, it doesn't let things pass through. In the structure of the brain, the way the cells are made, when you were studying it in part 1, do you remember some of the cells, like for example, the oligodendrocytes? The ones that actually were this great big huge cell, and it looked like they stretched out these arm-like extensions and wrapped